Hello everyone, I am Saeed. I'm a cognitive science graduate. I've just got my master's degree and I'm recording these videos for the purpose that, let's see Python for neuroscience. How does it look like and why to do it at all? I found actually recording videos and sharing with people kind of interesting. Very recently, a few of my friends asked for a short course for they are neuroscientists as well. They are actually enthusiasts of this field. They wanted to learn some Python for this, for their projects, for the research they want to do in this field. So they asked and I was happy to do so. And then I discussed it with myself, okay, why not record a few very short series of videos that people can watch and get an idea of what's happening. You don't have to be a scientist, neither I am. I'm just an enthusiast of the field, trying to figure out, trying to learn. I will make some mistakes, of course, because I don't know everything. I'm just learning myself. These videos would at least make myself understand some of the topics better, and for some would be a good starting point. There are tons and tons of better courses that do approach this specific topic even much more in detail and better than me, but this is fun. I like to do fun stuff, it's one way to learn. And if you ever come across these videos, please enjoy and let me know if there is anything wrong here. Okay, basically what I'm going to do is I will use Python in neuroscience with starting with and discussing why Python, not other tools, not other languages, plus what can we do, and basically at the end of these short sessions I will be doing one actual analysis in the field of neuroscience using an actual open source data and see what's going on, what can we see. You might be just maybe that would get you going. Maybe that would just make you interested in the field. Of course, I'm looking for that as well. And then as a computational neuroscientist enthusiast. Okay, why this matters? Let's basically see. When we are trying to study brain, you can't just open it up on living human beings. It's difficult, it's dangerous. So we record its activity using various tools like electroencephalography, functional magnetic resonance imaging, or fMRI, EEG for the first one, other tools like PET scans, and etc. So basically, we try to see and take a look inside of the brain without needing to open it up. The tools that do this for us provides thousands and thousands of lists of numbers that scientists try to make sense of it. Okay, what am I seeing? What am I dealing with here? That's why you pick up a programming language and start figuring out if you can make sense of the recording you have created. For example, one of the keywords that if you're interested in neuroscience, specifically in computational neuroscience, you will be seeing a lot is like connectivity matrix. It's basically a grade of correlations between the brain regions. In order to draw and create and compute this type of matrices, you'll pick up a language and start doing it. So let's go on. See, okay. Yeah, I chose Python. Python is my favorite language. It's my first language. It's not my first language. I started learning programming from C# myself, but I found Python much more fun. I started learning Python when version 2.7 was released back then. I found that very interesting. I loved the concept of object-oriented programming, which, if you want to learn more about it, there are tons and tons of courses on Python, Python basics, Python for anything, even Python for neuroscience, tons of courses. I found, recording these videos fun for me, so I do it. I basically try to not to care if you like it or not, but, if you ever do, I would be happy to know. So let's see. Look at these, 3 lines of code here. Basically what it does, it will acquire data. I'm not teaching anything, okay? We're just reviewing. We will be reviewing some some concepts with them together, and if ever one of us at least learn something, good for us. Look at these 3 lines of code here. Let's run it and see what happens. Okay, we acquired data. How fun. Let's plot it. Okay, one of the purposes of basically learning programming is to illustrate and basically plot the data that you're seeing so you can actually observe it with your two eyes. Let's see. How cool. The data we just acquired is actually a recording of the medial default mode network in brain, one of the participants in this dataset. How interesting. Okay, these are just ups and downs. You sure this is anything meaningful? Yeah. That's where science comes in. You basically turn something into numbers and try to figure out if those mean anything. So, these wiggly lines you see here in the medial part of the default mode network, it's like default mode network is basically like the celebrity of the brain networks. Talked about it a lot. It's actually very interesting, but there are other networks as well. So, basically because it is one of the best studied systems, one of the well-known systems in the human brain. So every bump you see here is basically 2 seconds of scanner time. Device used to scan the brain. And basically 5 lines of codes, download the data, and here you are already starting to see how does those signals look like. Okay, why Python specifically? Aren't there out there like other languages? No, from what I know, actually some of the some of the very professional and good laboratories labs that study brain are actually still using MATLAB. I did get the chance to work with MATLAB and some of its toolkits. Okay, not fun, not free, and not open source. Python won on a different axis. Python is free. Python can run anywhere, on any device, without caring about its specs. And basically the neuroscience community has built like enormous amount of open tooling on top of what Python already provided. So it's the tools that we get to work with studying the brain in Python are basically many well-maintained with like thousands of professional programmers and scientists contributing to those tools, and they're free to use without needing to pay. And most importantly, they're open source, so you can actually find out what's happening out there and back there if you would want to. So here's a rough count of some of the well-known and well-maintained tools and toolboxes that each of the languages will provide us in comparison. Let's plot it and see. Also done in Python. I would count 10 of them in Python, which are very well maintained, published and keyworded in many scientific papers, published and peer-reviewed scientific papers like MNE, NiLearn or NeLearn, depending on how you pronounce it, and they have like NiBabble or NeBabble, Brain2, Nest, which is Nest is basically Python API for brain, and then the API of it is written in Python. Okay. And there's DP or DIP, I don't know how to pronounce those, basically I think it's personal. So they have Python interface, Elephant, Neo, and PyNN. Just some of them. There are tons of other tools, but these are some of the very well-known, maintained, and published toolboxes that you would find free to use and open source in Python. I did get across MATLAB to use. MATLAB itself is not free. You have to pay, and you have to pay a lot of money in order to be able to access it, even as a student. But considering that, I've had experience with working with like tools like SPM, EEG Lab, which basically is like when you do electroencephalography or EEG recordings of the brain, you want to export the data, work with it, see what's happening, you use EEG Lab. Then we have Field Trip, Brainstorm, and Khan, which for example, I used SPM and Khan for functional magnetic resonance imaging or fMRI data pre-processing. So we pre-process data using Khan. Also in another project, we used SPM. I do have some experience with R as well. Not many. The community is not as large as what we see in Python. So like two of them are like BrainGraph and EEG Kit, some of the very famous and well-maintained ones. And then we have C and C++, the big boys of the programming field. We have FSL or Fossil actually, They have fMRI and FreeSurfer. These three, which are written in C and C++, are basically the gold standards of the neuroimaging field. But you can't just pick it up and see what's happening here. C and C++ are not easy to interpret for us, or for us newcomers to the field, or we're just people that are interested to see what's happening. So the comparison talks for itself. Okay, and in order to do what I'm doing here, see the codes that I've been running, everything is free, open to you to just pick it up and run. You don't even have to install a single tool in this course. Every notebook are already put in the repository of mine in GitHub, which I will share. You just click on the link, it opens up in your browser, and you can pick each of the sessions to be ran on Google Colab, which is another tool that is free to use, at least to some. Like the free tier to use is like very generous. You don't have to even install anything. So this is for you that are just interested and want to see what's going out there. Just go and mess around, run some codes, see what's happening, in order to find out. All done and, made available for you. Just click on the repository and pick each of the sessions you want. It will open on Colab for you to run the codes and see what's happening. So I will do 11 other sessions as this one. Very short, very quick, and easy for you to pick up and, be interested in computational neuroscience. So yeah, that would be it for now. Bye-bye.